welcome to week 8. So, this is our scheme of work. So, we are now here, week 8. And in this week, we should discuss about the hypothesis of two population means uh, by using the Z distribution, by using the T distribution, equal and unequal variances, and by using the P value, as well as testing of hypothesis of two dependent population means. Okay, so again, as you can see here, the subtopics in this chapter, okay, in week 8 here is actually the same as in topic 2. It is just that in topic 2, again, we discuss on how to calculate the confidence interval for all of these um, cases, right? But now, instead of calculating the confidence interval in topic 3 here, we are discussing on how to calculate the um, test statistics by using T calculated or Z calculated, depending on the case, whether the standard deviation or variance of the population is given or not given. Okay, and I think in the last class, we have only one example left for one population mean. We have one example left. Okay, now let's look at our module. All right. So this is an example, the last example for one population mean before we discussing the two population means. Yeah. Okay, again, this is a Minitab output, and usually in the test or in the final exam, there will be a lot of Minitab output, and you must be able to understand or read the output. Okay, and now let's look at example 7. The Minitab output for the data in example 6 is as given below. Use p-value. Now, instead of using the test statistics, the question asks you to use the p-value to test if the average mean daily salary substitute teachers in school is more than 55 ringgit per day. Again, what is stated in the question is our alternative hypothesis. Okay, more than 55 ringgit per day. Or if you confuse, or if you maybe do not remember how to write the hypothesis, okay, you can also refer to the output here. Test of mean is equal to 55 versus greater than 55. So from there, you can come up with your hypothesis, which is our step 1 hypothesis, and from the output you can uh, take mu is equal to 55 as our null hypothesis. Remember, for the null hypothesis, to be safe, you just use the equal to symbol for all of the cases in chapter 3. Okay, for all of the cases, just use equal to symbol. And for this one, this is actually our alternative hypothesis. So our alternative hypothesis is mu is greater than 55 ringgit. And again, in this one, okay, in the output here, the output did mention 55% lower boundary. So it means that our significance level, again, it is alpha 1 minus 0.95 from here, 0.95, and our alpha is equal to 0.05. And step 3 uh, in the previous example, we use test statistics, right? This one. This is the test statistics in step 3. But now, since the question asks you to find to test the hypothesis by using p-value, so step 3 will be our p-value. Okay, and the p-value is this value, which is equal to 0.034, right? And step 4 is the decision rule. If using the p-value, we only have one decision rule for all of the cases. Okay, the p-value is reject H null. Oops. Wait. Reject H null if p-value less than alpha. Always use p-value less than alpha. And I would like to highlight this thing because the common mistakes done by the students is you tend to compare, for example, p-value with other value, or maybe up here, this is our test statistics, right? So the common mistake done by the students is comparing these test statistics. This is t calculated. You compare with alpha. No, this is not right. Again, only p-value can be compared with alpha, okay? And if you calculated the t calculated, then you need to compare with the t critical value. Remember that one, okay? Because this is the common mistakes done by many students in the final exam or in the test. So please make sure that if p-value compare with alpha, if t calculated compare with the t critical value, if z calculated compare with the z critical value. So for this one, rejection if p-value less than alpha, and our p-value is again 0. What we can do is, since p-value is equal to 0.034 and alpha is 0.05, greater than or lower than, p-value greater than or lower than alpha in our case right now,
Lower than.
lower than, lower than. Okay, so uh see, so in step 5 for the decision, because p-value is less than alpha and we can reject H null if p-value is less than alpha, so our decision is we can reject H null. Step 5, reject H null, and step 6 is the conclusion. Remember, if using test statistics up here, test statistics in the previous example, we have 7 steps. And if using the p-value, we have 6 steps only. And for the conclusion, if we reject H null, what we can do is, what we can conclude it is sufficient or insufficient.
Sufficient.
Sufficient. Sufficient evidence to conclude that, ambil balik apa yang soalan minta. The average mean daily salary for of salary of substitute teachers in school is more than RM 55 ringgit per day. So the conclusion here must be equal to the conclusion by using the test statistics. Sufficient evidence. This is also sufficient evidence. Okay. So remember, yeah, this one, regardless of the approach or method that we use, we should get the same conclusion, the same decision. If the confidence interval, if the significance level that we test the hypothesis is the same. Kalau dia ada different significance level. For example, in example 6, we use 0.10. In example 7, we use different significant level. Ada kemungkinan that you will get different answer. But if the significant level is the same, then usually we will get the same answer. Right. Any question before we move to the next subtopic, hypothesis test of two population means? Any question?
Tak ada, Doktor.
Thank you. How about others? Do you have any question?
No.
All right. Thank you.
Doktor.
Sorry? Tak ada. Okay. All right. So if there is no question, then let's discuss 3.2 hypothesis test of two population means. Again, for two population means, it is the same as in the chapter 2, in which we have two independent variables, and we have two dependent variables. For two independent variables, there are how many cases altogether? 3. The first one is when the variances of the two populations are known. The second one is variances of the two populations are unknown and it is equal. And equal, if you remember, for this one we need to find the pool standard deviation. And the third one is when the variances of the two populations are unknown and unequal. For this one, you don't have to calculate the pool standard deviation, but it is quite complicated to find the degree of freedom, right? Because for this one, the degree of freedom is simple, which is n1 plus n2 minus 2. But for the third case, the degree of freedom is s1 square over n1 plus, right? Plus s2 square over n2 square over s1 square over n1 minus 1, if I'm not mistaken. Sorry, over n1 square of minus 1. Ke yang ni ke atas? I dah lupa dah. Mungkin terbalik kot. Rasa macam terbalik je. Terbalik kan? Let me check. Let's check in our chapter 2. Okay. Okay, betul. This is the formula. Okay, this is the formula. All right. But don't worry, the formula will be given. Um, the other case is for two dependent variables. This one you need to find the difference, and everything will be based on the difference. All right. Now, for two population means, and to test the hypothesis, again, the same as in chapter 2, you have two tail test, right tail test, and left tail test. For the two tail test, by the way, before that, the null hypothesis is always mu1 minus mu2 is equal to 0. Mu1 minus mu2 is equal to 0 because why? For two population means we want to find if there is any difference in the means of the two population. If um, if it's include 0 in the confidence interval, for example, then we concluded that there is no difference in the means. But now we are using the Z calculated or the T calculated to test whether uh, is there any difference in the mean of the two population. And for the two-tailed test, the mean is unequal to 0. For right-tailed test, mean 1 minus mu2 is greater than 0. And for the alternative hypothesis, mu1 minus mu2 is less than 0. And for the test statistics, we will use point estimate minus population parameter over standard error. It is actually the same as the one population mean, but now since we have two populations, our point estimate is x bar 1 minus x bar 2. So if you remember in calculating to calculate the confidence interval by using the Z calculated, the confidence interval of the difference is equal to x bar 1 minus x bar 2 plus minus z alpha over 2, and you have the standard error of sigma 1 square over n1 plus sigma 2 square over n2, right? But for the z calculated or z statistics here, the statistics, this is the formula x bar 1 minus x bar 2 minus mu1 minus mu2. And mu1 minus mu2 here is always equal to 0. It is always equal to 0. All right. And if the standard deviation or variance of the population is unknown, we need to use case number 2 or case number 3. This is case number 1, case number 2, and case number 3 for two independent sample. This 3 is for two independent, sorry, it is not sample, it is for two independent variables. And we will use this one for two dependent variables. For the last one, you need to find the D, and the null hypothesis is mu D is equal to 0. Okay, this is what I mentioned earlier for case number 3, when the variances of the population are unknown and unequal. We need to find the degree of freedom by using this formula. And when the variance of the populations are unknown, but it is equal, use this formula where you have to find the pool standard deviation. Okay, now I hope you still remember, yeah, about that one? Because it will help you to identify which formula to be used to calculate or to test the hypothesis. Now, let's look at example 8, in which example 8 is actually the example number 14 in chapter 2. In chapter 2, I believe that we have calculated the confidence interval, but now we are testing the hypothesis by using the um, either Z calculated or the T calculated value. Now, let's read together. A survey of low and middle income households show that consumers aged 65 years old and older had an average credit card debt of 10,235 ringgit. So our X bar 1 is equal to RM 10,235 ringgit. And consumer in the age 50 to 64 years old had an average credit card debt of RM 9,342. So this is our second mean of the sample, 9342. At the time of the survey. Suppose that these averages were based on the random sample of 1,200 and 1,400 people for the two groups respectively. So N1 is 1,200 and N2 is 1,400 people. Further, assume that the population standard deviation. Now, it is mentioned that the population standard deviations for the two groups were 2,800 ringgit and 2,500 ringgit. These two are the population standard deviations. So if the population standard deviations is given, this one, population standard deviation is 2,800 and second one is 2,500. From here, from this information, you already know that you need to use the Z calculator. Z calculated because the population standard deviation is given. Okay, let mu1 and mu2 be the respective population means for the two groups, people aged 65 years old and older and people in the age of 50 to 64 year age group. Test at 5% significance level. Again, in chapter 2, the question will ask you to find, for example, 95% confidence level, or at 95% confidence level. 95% confidence level is equal to 5% significance level. So our alpha is equal to 0.05. Okay, 0.05. Whether the population means credit card debts for the two groups are different. So in this case, you nak guna one tail test or two tail test? Class, one tail test or two tail test?
Two tail test.
Sorry? Two
Two
tail
tail.
test. All right, correct. Two tail because we are testing um the hypothesis at two tails, the right tail and also the left tail, because the question did not mention whether we want to test apa, greater than or lower than. So because of that, Our hypothesis, step one. Oops, hypothesis H null is, okay, we are currently discussing two population means. So the H null for two population means is mu1 minus mu2 is equal to 0. mu1 minus mu2 is equal to 0. It is always like this for two independent populations. And the alternative hypothesis is mu1 minus mu2 are different. So two-tail is not equal to 0. Not equal to 0. What is mentioned in the question here is our alternative hypothesis. Step 2. Step 2 is the significant level. Which one is our significant level? This is our significant level, 0.05 or 5% significant level. So our alpha is equal to 0.05. Step 3 is the test statistics. Okay, for the test statistics, what is important is you need to know whether to use the one population punya formula or two populations punya formula. In our case, we have two populations. One group is 65 years old and older, and the other group is 50 to 64 years old, right? 50 to 64 years old. So we have two groups, and we want to know whether these two groups are have equal or unequal debts, household debt. So, and in this question, it is also mentioned that the standard deviations of the two populations are given. Jadi you dah tahu that you need to use the Z calculator. Okay. So the test statistics is Z calculated, and from here you just need to go to the formula. Okay, go to the formula and check which formula to be used. If you don't remember the formula, so our formula is x bar 1 minus x bar 2 minus mu1 minus mu2. This is again, it is always equal to 0. So for me, it is optional. If whether you want to include it or you can exclude it from the question, from the formula, because it is always equal to 0. And for the denominator, it is square root of variance of 1 over n1 plus variance of the second group over n2. All the information required is given in the question. So you just need to replace the values into the formula. So we have 10, oops, 10,235 minus 9,342 minus 0 over square root of 2,800 square, yeah? Because the question just gives us the standard deviation, and in the formula you need to use the variance. All right, over 1,200 plus 2,500 square over 1,400. All right. And please calculate the Z. What is the Z value?
8.5153.
Sorry? 8 point?
5153.
8.5153. Thank you. That is the third step. And step number 4 is to find the critical value. Since we calculated Z calculated here, so you need to compare Z calculated with the Z critical value. Please do not compare with alpha, with the T critical value. You need to compare with the Z critical value only. And in our case right now, we have, or we are testing a two-tail test. So our Z critical value is Z alpha over 2. Z alpha over 2. Why? Because kita buat two-tail test. Z alpha over 2 is equal to Z 0.025 lah. Because this is alpha. Alpha over 2 is equal to 0.025. Okay. So what is Z 0.025? You need to go to the statistical table and find Z table. This one, right? Okay. From this table, let me. Okay. So from this table, find 0.025. So this one is 0.025. The value is 1.96. From table 4, find 0.025 and read the value. It is equal to 1.96. So go back to our module. This value is equal to 1.96. And for step 5, Step 5 is the decision rule. So for two-tail test, the decision rule is reject H null if Z calculated is greater than Z critical value. I think I will just put it in one word. If Z calculated is greater than Z critical value, or if Z calculated is less than negative Z critical value. Okay, for this one, why? Since we are testing a two-tail test. A two-tail test means that this is the distribution. So our hypothesis now, we are testing at the right tail, on the right tail, as well as on the left tail. And if Z calculated is a positive value, this one is positive value, right? Okay, greater than Z critical value. This is our Z critical value, and this one is negative Z critical value. It is either 1.96 or negative 1.96. This is 0. If our Z calculated is positive, compare it with the positive Z critical value. But if our Z calculated is negative value, compare with the negative Z critical value. But this time, in this example, we have positive Z calculated, and you just need to compare with the positive critical value. And Our Z calculated is 8. Say that it is around here. This is our Z calculated. 8.5153. Okay, so it falls under the rejection region. This is the rejection region. That is why we reject H null if Z calculated greater than Z critical value. But let's say if your Z calculated is, for example, yeah, sekejap. Let's say this is not here. Our Z calculated is, oops, is here. It is positive value, but let's say we have 1.5153. For example, it will be here. We still need to compare this value with positive Z critical value. But if it is here, Z calculated is equal to 1.5153, we fail to reject H now. Okay, we will only reject H now if it is greater than the Z critical value. Okay, any question? No question. All right, so compare the two values. Since Z calculated is equal to 8.5153 and Z critical value is equal to 1.96. It is greater than, greater than, greater than. So remember, positive Z calculated compare with positive critical value. So step 6 is the decision. And for the decisions, since it is Z calculated is greater than Z critical value, the decision is to reject H now. If you get something like, again, 1.5153, it is not greater than Z critical value, it is less than Z critical value. If this is the Z calculated, then the decision is failed to reject H now. But this time we reject H null because our Z calculated is 8.5153 greater than Z critical value. So the decision is again step 7 conclusion. There is sufficient evidence to conclude that, take it from the question, the population means credit card debts for the two groups are different. The population means credit card debt, the population means credit card debt for the two groups are different. This is from the question. Any question? Okay, by the way, since this is from example 14 of chapter 2, let's check what we got in chapter 2, the answer. Example 14, it should be the same. Oops. Example 14. We are 95% confident that the mean difference household debts of the two populations is between 687. Wait, yeah. Okay. Is between RM 687.46 and 1098.54. If you still remember, since our lower boundary is positive and upper boundary is also positive, what we can conclude, the two populations have unequal or different household debts. So what we got in our current example, example 8 in chapter 3 is equal to the example 14 in chapter 2. Sama kita dapat dia. Okay, satu menggunakan confidence interval, satu lagi menggunakan test statistics. I hope you can relate, yeah. I really hope you still remember this one. If positive for confidence interval, if we get positive value, then ada different. Negative value also significant different. But if we have negative and positive value, then it is equal. It is not different. Right? So it is the same. The answer that we get is the same. Can we proceed?
Boleh, Doktor.
All right, thank you. Example 9. Example 9. A sample of 14 cans of brand 1. Okay, now we will have two brands. Say that brand 1 and brand number 2. Can I clear this one? Previous example? Can ya? I will clear the previous example. By the way, don't worry, because I will share with you the recorded video for this class later. Can you please check if I did start the recording? Then,
Dia rasanya ada.
oh, all right. Thank you. All right. Now, let's discuss example number 9, brand 1 and brand 2. So a sample of 14 cans of brand 1 diet soda, 14 cans. Then we have N1 is equal to 14 cans. Gave a mean number of calories of 23 per can with a standard deviation of 3 calories. So X bar 1 is 23. Mean number of calories of the 23 per can with a standard deviation of 3 calories. So this is the standard deviation of the population or of the sample? This is the standard deviation of the sample. Correct, sample, because it is based on these 14 cans of diet soda. And again, the word is, sorry, the sentence is, it is continuously from the mean number of the 14 cans of diet soda. So our S, now we have a sample mean, not the population mean. 3. Another sample of 16 cans of brand 2 diet soda gave the mean number, 60 cans, mean number of calories of 25. So X bar 2 is equal to 25 with a standard deviation of 4. So the standard deviation is equal to 4. At 1% significance level, so our alpha is 0.01. 1% significance level. Can you conclude that the mean number of calories per can are different? It is also different. So again, it is not mentioned whether brand 1 is greater than brand 2 is lower than brand 1. It is the question just mentioned are different. So bila are different, we know that we need to use the two-tailed test. Assume that the calories per can of diet soda are normally distributed for the two brands and the standard deviation of the two populations are equal. Okay, are equal. So when equal, you must remember this in this case, you need to interpret the situation. The first one is standard deviation standard deviation of samples are given. Okay, are given. So from here, you know that you need to use the T calculator. And we have two different cases. One is for equal variances and the other one is unequal variances. And from this one, from this information are equal, so you know that you need to use the TCAL that has a pool standard deviation because the two populations have equal standard deviation. All right. And the last one is, it is a two-tailed test because the question say that ask us to find whether the two brands of soda are different. So now you already know which method to be used. Okay, so let's proceed with the step-by-step approach again. Step by step. First step is the hypothesis. H null is again, it is the same one. Mu1 minus mu2 is equal to 0. And the alternative hypothesis is two-tailed test. Two-tailed test is mu1 minus mu2 is not equal to 0. It's different lah. So this is meant by the different. Not equal to 0 is different. And step 2 is the significant level. In our case, the significant level is equal to alpha 0.01. And step 3 is the test statistics. I think I will, oops, write step 3 here. Step 3, the test statistics. Remember, for this one, the standard deviations of the population is not given, but what we have is the standard deviation of the sample. Because of that, we need to use the T calculated, not the Z calculated. And for this one, it is mentioned in the question that we have equal population standard deviation. So the formula is x bar 1 minus x bar 2 minus mu1 minus mu2 over pool standard deviation times 1 square root of 1 over n1 plus 1 over n2. Right? So this formula will be given in the formula appendix. In the appendix, you need to know lah which formula to be used. And in this question, the pool standard deviation is not given. Therefore, you need to calculate the pool standard deviation first. And the pool standard deviation, the formula is given by n1 minus 1, okay, times the variance of sample number 1 plus n2 minus 1 times the variance of sample number 2 over n1 plus n2 minus 2. So from the question or from the information that we have obtained earlier, we have 14 for sample number 1, 14 samples, 16 for sample number 2, and the standard deviation is 3 and 4. So this one is 14 minus 1 times 3 squared, because in the question, this value is the standard deviation, but in the formula, we need to use the variance. Okay, so you need to square the value. And for sample number 2 is equal to 16 minus 1 times the variance for sample number 2 is 4 square over 14 plus 16 minus 2. So calculating this, what will you get? What is the standard deviation? Sorry, pool standard deviation?
3.5707.
12.5775. Have you
3
square root the value?
perpuluhan. Ya dah.
Okay. 3 perpuluhan
5707.
5707. All right. Thank you. 3.5707. Okay, now this value you can insert here. Now we can calculate the T calculated. So the T calculated is equal to x bar 1. X bar 1 is equal to 23, right? 23 minus 23 and 25. 23 minus 25 minus 0 over SP. What is our SP? It is 3.5707 times square root of 1 over and 1 is 14 plus 1 over and 2 is 16. So what is the T calculated?
Negative 1.5305.
Negative 1.5305. All right. So now you have a negative value. Okay. Previously we have a positive value, right? In our previous example, we have positive value for Z calculated, but now we have a negative T calculated. All right. So since we have negative T calculated, wait. Now we proceed with step 4. First, step 4 is to find the decision rule. It is the decision rule. Critical value. Sorry. Step 4 is not the decision rule yet. It is the critical value. Okay. So now we have calculated the T. So you need to find the T critical value. The T critical value is T alpha over 2 and the degree of freedom is n1 plus n2 minus 2. This is also equal to T. What is our alpha? Alpha is 0.01 and alpha over 2 is equal to 0.005. Why alpha over 2? Because we are testing the hypothesis at two tail tests with two tail tests. Okay, two tail tests. Remember, two tail tests, you need to divide the alpha by 2 in the test statistics, for the test statistics. All right, so 0.005 and the degree of freedom here, I think I will just use n1 plus n2 minus 2. So this is the degree of freedom. Okay, it is equal to 28. So to get the T critical value, go to the statistical table, find T 0.005 by referring to the table number 7 here, right? So let's find T 0.005. This is the alpha, and our degree of freedom is 28, right? So the value is 2.763. 2.763. Go back to our module. So the value here is equal to 2.763. Now proceed with step 5. This is the decision rule. Okay, now we use two-tail test to test the hypothesis. If two-tail test, the decision rule is reject H null, H null if T calculated is greater than or equal to T critical value or t calculated is less than or equal to negative t critical value? Since we have a negative t calculated, then we will use this one. Okay, we will compare the t calculated here with the negative t critical value here. So since t calculated is equal to negative 1.5305 and the t critical value is equal to negative. Okay, you kena tambah negatif kat depan 2.763. Negative 1.5305 is greater than or less than negative 2.763. It is greater than. Okay, if we can sketch, this is right, this is left. Two-tail test. But since our value t calculated is negative, so we are testing at the left side lah, on the left side, sorry. So this is our negative t critical value 763, and this is our this is our t calculated. T calculated is equal to negative 1.5305. Does it falls under the rejection region? No, because it is greater than the T critical value. Okay, kita reject kalau dia less, but now we get greater than. So, the decision is step 6. Decision is we fail to reject H now. Fail to reject H now. And the last step conclusion is there is insufficient evidence to conclude that dot dot dot. The dot 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 here is you can get it from the question or from the alternative hypothesis. But and fail to reject, if the decision is fail to reject, so the conclusion is insufficient evidence. Okay. Any question?
Tak ada.
No question? No? Okay. So if there is no question, I will stop the class here until example number 9.